Alright, now we're going to be looking at some basic differentiation rules. This is where things get really good. We've been using this limit definition of the derivative so far, and it's great. It is very important that we understand that. We will still need to know that, and I will explain that. But now we're going to look at some rules that can make things a lot quicker and easier and more efficient, which is always better. Sometimes. So, first rule, constant rule. We have the constant rule, and then we have the power rule. They're really the same thing. So these are not things that you should be memorizing. Well, the power rule you should memorize, but the constant rule you shouldn't memorize. You should just understand it, because again, you should understand what does a derivative represent. The derivative represents the slope of the tangent line. What is the slope of a constant? The slope of a constant is 0. So therefore, the slope of the tangent line will be 0. So that's why our constant rule says that d dx of c, where c is a constant, is 0. So the derivative with respect to x of c, a constant, is 0. The derivative with respect to x of the function x is 1. Again, that should be common sense. What does a derivative represent? It represents the slope of the tangent line. What is the slope of the function x? The slope of the function x is 1. Therefore, the derivative of this, therefore the slope of the tangent line will also be 1. Now this is the good one though, the power rule. And again, this actually directly relates to both of these as well. So the derivative with respect to x of some function raised to the nth power is n times x to the n minus 1. So if I do the derivative with respect to x of 6, I know that this is 0. But again, this relates to this power rule because I can think of 6 as 6 times x to the 0, and then if I bring the 0 down and subtract 1, well, 0 times anything is 0. Here, if I look at this one, so this is x to the first, so if I bring the 1 down, I end up with 1x to the 0. But what's anything to the 0 power? It's 1. So that's how I end up with 1 here. So d dx of 3x squared minus 5x plus 2, I can do the derivative of each of these individually, and so I'm going to end up with 2 times 3x to the first minus 1 times 5x to the 0, and then plus 0 times 2x to the negative first. That might look really confusing, and I definitely would not write it like this. But basically, I'm thinking of this as x to the first, and this as 2 times x to the 0. And so that's how I'm doing this power rule thing. But really, what we want to get from this is that the result is going to be 6x minus 5. Okay, that's the power rule. It just tells us bring the power down and subtract the power by 1. Next are a couple of rules to help us with combining different functions. So addition and subtraction, we actually just saw this on the last example right here, and that is essentially that if I am doing the derivative of functions that are being added or subtracted, I can do the derivative of each of them individually. And, whoops, that's our conclusion. So what I mean by that is I was doing the derivative of this entire function, but really I just did the derivative of each term individually. So that is our addition and subtraction rule. Our constant in front rule is telling us that if I have a constant times a function, I can just bring the constant in front and then do the derivative of the function. And again, I actually demonstrated that here. The 3 did not affect how I did the derivative. It just got multiplied by the 2 when I brought it down. So that's what this is showing us. It's saying that we can think of this, and again, you don't need to write it this way, but I can think of this as 3 times dx of x to the 6th, and I know d dx of x to the 6th, sorry, I'll put parentheses around that, is, so then this would become 3 times 6x to the 5th, so I get 18x to the 5th. That's all it's telling us. Again, it's very formal and showing us that we can bring the constant in front. We really just want to understand that when we bring the exponent down, it gets multiplied by the constant. So pause the video, try this example on your own, unpause when you're ready to check. Oh, by the way, what I mean by that is you are trying to find what is f prime of x. Pause the video. Okay, so we should end up with f prime of x is 20x cubed plus 9x squared minus 1. And again, how are we getting that? I bring the 4 down. 4 times 5 is 20. I subtract 4 by 1, and that gives me 3. So 20x cubed plus I bring the 3 down. 3 times 3 is 9. And then I subtract 1 from 3. That gives me x squared. This is just the derivative of x, which is 1. But since it's minus, it's a negative 1. The derivative of a constant is 0, so I don't write anything. Crucially important, we understand the power rule. Not to be overly dramatic, but it could just save your life. There are at least 3 occasions I can think of where it saved mine. Not literally, but maybe.